we talked about aerospace and we talked about healthcare, and our podcast is designed to talk about how material science appears in our everyday lives as well.
Yeah.
So I wanted to hear what you thought about, where could an average American expect to encounter titanium and its alloys in, our everyday life?
I think I have a bad answer for you, unfortunately, which is either probably not or you got to be rich. It's so for sure, like the stuff that you have in your house has touched titanium in its past. So a lot of, let's just say, cleaning chemicals underneath your sink have been processed in plants that have titanium tubing of some sort, or perhaps the solid gold of toilet paper these days had some titanium in its pulp and paper processing facility because it does good things in those types of caustic and corrosive environments. So when you look at your toilet paper, you might not be touching titanium, but that probably did touch titanium at some point in its life. So as consumer goods, the actual amounts of titanium you see are going to be relatively few and far between. But the stuff you might take for granted that was processed in a plant that contains titanium is everywhere, probably in piping applications or, impellers, things like that, that could be in a nasty bath that's being used to, either oxidize or reduce something into a material that it once was not. So, but if you want to talk about stuff that somebody has in their house today, one of the obvious things is jewelry, right? So you've probably tried on or know somebody that has a watch that's got a titanium band on it. So it probably looks a lot like stainless steel from far away, but when you pick it up, you do that thing where you're expecting something to weigh 30 pounds and it only weighs 2. Titanium is finding its way into wedding bands and things like that as you're looking for something unique to say, like, oh yeah, my wedding ring's titanium for whatever reason. But like I said, the drill bits are coated in titanium nitride. You could see things like bike frames or tennis rackets, or there's a couple of places you could see it, but everything that I just listed was something that you're probably going to need to have paid for and you'd know about. You're not going to accidentally stumble into your kitchen and realize your measuring spoons are made of titanium. There's other materials to use that are just more obvious than titanium to use for most things around people's houses. It does exist in a world where there's a reason for you to have opted for that premium, and that needs to have been a conscious choice, or you probably will know something about it when you had made that decision. You mentioned biomedical stuff a while ago, and as we as a medical community are increasing people's lives and livelihood, you're going to see more and more people that are bionic, right? And I say that, with a little bit of a wink here, because your dental implants or a new hip cup or getting plates and stuff that are, related to bad bone breaks and things like that, you will probably know somebody in your life who's got titanium implanted in them. And so in fact, my mother's got a couple of pieces in titanium, and I always ask her to ask her surgeon if he can send me the material cert. And that's kind of a joke, but what it's made out of and kind of where, the manufacturer of that medical device is. So I would wager between the three of us, one of us is going to have something titanium in us before the time we all move on to greener pastures here. Yeah. I think
Tom
it's Tom.
Yes.
I mean, it's good for me, right? I get titanium.
So, Puneet, to answer your question, in general, people aren't just going to stumble on titanium. They will either be pointed out to them, they will have paid a premium for it, or their doctor is going to give them no other choice.
Which is to say, though, that even though a average person may not work with titanium or experience titanium in their day-to-day lives, which is to say, though, that our lives are enabled by being able to use titanium in a number of manufacturing applications.
Yeah, exactly. And so, I mean, if you were talking to somebody who worked at, ExxonMobil or one of the companies that processes chemicals all day, every day, they're going to take for granted the fact that commercially pure piping exists. You could, for instance, you go on McMaster Car right now and buy a piece of titanium. It's out there. You can buy it as a person. You could make a doorstop out of it or a business card out of it. But the question is, why are you doing this? Because at the end of the day, a lot of the thing that rules the day is somebody's pocketbook or wallet. Yeah, and so there's no reason to go after it if there's something else out there that does a much, much better job cost-wise with perhaps no discernible detriment for having chosen something else.
So aside from what we deal with every day, we've started to touch on a number of future applications, but totally industry agnostic, what do you see as being a potential future application for titanium and its alloys that you see to be potentially promising?
titanium in its own right, I'm not going to say it's played out, but of the community that cares about titanium, there's not been huge strides made in the metallic version of titanium in a while. So we're finding new things to do with it, pushing the boundaries, finding coatings that you could make out of it or put on it to do some unique and novel things. So when you start to think about perhaps the exotic alloys or unfamiliar ones, you start to think about things like the titanium aluminides. So titanium aluminide being an intermetallic material that contains titanium, aluminum, and niobium. They're starting to make turbine blades out of that for the aviation industry. So you get the benefit of having lower density aluminum alloyed with your titanium. So we're already talking about light alloys and how titanium's pretty good at that. So now you add a less dense material into that. And by the way, you're getting an intermetallic out of it, which actually withstands higher temperatures. So you've gone and blown away my prior statement to say that titanium is one of the best for high strength to weight ratios, but can also handle temperatures. Because now I'm telling you, go put this aluminum in there and it gets even better, right? It certainly doesn't come without its detractors or detriments, which is it is an intermetallic. It is enormously brittle at room temperature. There's papers out there that their findings are less than 1% ductility at room temperature. So if you just look at it funny, it's just going to shatter. But if you're going to put it in the hot section of an aircraft engine where all you really need to worry about it is the couple of cycles it takes, hot gases flowing by before it starts to gain some of its toughness. Yeah, it's got good applications in those situations. But again, I think titanium aluminide is even worse than Ti-64 with how often you're going to see it. I will never, ever in my entire life find a use for it in my house. I don't think. I can't, honestly, because my house is all room temp. I don't know what's going on if I'm at the applicably useful temperatures for titanium aluminide. I think that specifically the intermetallics of titanium are probably going to have their day probably in the somewhat near future as we're starting to recognize that we've kind of come up against what we might be able to do with the known materials inside of titanium. And now we're starting to use these ones that are hard to work with. So all of the titaniums to date are chosen because they have a use, but you can also manufacture them. Titanium aluminide is processable through electron beam melting, but you can also, and in the additive space, but you can also cast it. But the yields, so like first time yield of these parts are enormously different depending on the method with which you manufacture it. So in a casting, right, you're going to have odd cooling rates depending on section thickness. And with intermetallics, such a difference in thermal gradient is enough to crack the part and then cause it to be scrapped. Because of the hot chamber temp of EBM, you can actually start to think about tailored cooling rates and make sure that doesn't come down from temperature too quickly. So then you have much, much higher yield in the additive space in EBM. So you couldn't even process titanium aluminide in laser because of the speed with which a laser part would cool off. You really get the benefit of titanium aluminide in EBM because of the vacuum environment and how slowly the powder bed cools off once you actually start to begin processing parts.
So to speak to the future a little bit more, and obviously additive has come up a few times in this conversation for some reason. I don't know why. However, to speak a little bit to the future of titanium, why is titanium such this popular material in this additive manufacturing space?
The reason that they have applications in titanium first and foremost was because of the industries that required it. So when you start to look at what we've talked about already, you have aerospace, medical, and some of like the high-end automotive or consumer goods applications are the ones that can afford this relatively expensive manufacturing technology as it's new. And so those people had the applications that were then titanium. So then titanium got brought into the fold. And so as a little bit of kind of background as to where RCAM, so the electron beam GE additive family comes from, is the fact that they had this brand new novel technique of essentially layer by layer additive manufacturing. And they said, well, who is interested in such a technology? And then that pointed them to the medical field, and then the medical field pointed them to titanium. So there is no intrinsic reason that EBM and titanium play together super nicely. It's a coincidence that they do. It's nice that RCAM has figured out how to do it very well, but it was a development of the technology, find a customer such a thing, what's critical to their quality. And that would be the actual biocompatibility, therefore titanium. So to say that titanium in the additive space plays well is kind of a backwards thought. It's really what industries does additive play in, and then what do those companies want for their applications? I promised you to round out with laser, and EBM and titanium, like I say, play quite nicely together because of the history in RCAM and the titanium using medical field. It's a little bit later to the laser game, not a whole lot, but a little bit. And so we actually experienced some problems with cracking in our titaniums inside of the laser field, again, because of residual stresses that can be built up and some of the heat modeling that goes on. So even to kind of push back a little bit on your statement, Tom, as to why titanium plays so well in additive space, I could tell you that to develop titanium on a laser machine is borders on horrible. Like, it's not a pleasant experience. So our customers say we want it, so we go make it work, but it's not a great material to develop.